is number one! Number one! Woo! Go Earth! Alright, good morning everyone! Today our class is going to be called Discover Earth because, at least in my opinion, and this is just how I feel about Earth, I think it is one of the best planets. Alright, and our goal today is to discover a little bit more about this planet that we call home and what exactly that means. And so with that, joining me in the studio to kind of help make sure that our images come in clearly and to answer any questions that you might have, I have Alicia, who's going to be helping a little bit with the background, but believe it or not, I'll be doing a lot of that with us today because we are using a special program that I'll get into in a little bit called Science on a Sphere. And Alicia's going to be helping support that today. And then we also have James that's going to be answering any questions that you might have. And so if you do have questions, you can go on ahead and text them on in 562-286-1838. And then if you're watching this when it's not Friday the 10th, I think, I'm sorry? The 20th! My goodness, my dates are completely wrong. The Friday the 20th, that's November, of course, at 10 to 10:30 in the morning, you can go on ahead and email us with any questions that you might have. Now, with our program called Discover Earth, our goal today is to be able to look at different kinds of data sets. And so, what we mean by data sets is by basically seeing information in a really cool way. So our goal today is to be able to look at lots of information through different colors, so it'll be I think, a very beautiful class as we get a chance to look at our lovely planet right here. Now, if you're interested in kind of joining along, we do have this program, Science on a Sphere, is a NOAA program, so it's part of the National Oceanic Atmospheric Administration, and if you just type in NOAA SOS or Science on a Sphere, that basically will bring up a program that you can kind of join along in. So if you're on a computer, that's one way you could join us. If you just have an iPad or an iPhone, or kind of like, well, not even an iPhone, but any kind of like cell phone where you have internet capabilities, you just want to search in Science on a Sphere, and you too can kind of join in as we look at different data sets. And so what's really cool is that you can join along with me as we basically navigate through our SOS application for today. So with that, we're going to start with the super basics. So I'm going to step off screen, and here we have our lovely planet Earth. I've mainly focused it on our lovely North American continent right here, and that's because, well, for a lot of us, at least regionally, right, this is what we call home. And so love for you just to kind of get our brains to warm up a little bit. And we'd love to hear any kind of comments that you might have or questions that you might have or any kind of observations. Feel free to text those in. But to get us kind of warmed up and our brains going today, let's go ahead and think about this, right? What are some colors that you notice on our Earth right here? And also, what do these colors represent? So, what do you notice? Well, I definitely notice that we have a lot of blue, right? So our planet Earth is about 75-ish% water, so we have a lot of water that's on our planet, so that blue definitely represents water. But can we find water anywhere else on this planet that's not blue? If you're thinking about white, absolutely, right? So we have clouds that are basically a lot of moisture that's in the air, so we see white as clouds. Then if you're thinking white as snow or ice, you got it, right? So here we have at our poles, we can't really see it down south, but definitely on our North Pole, right? The Arctic region right here, we can see that there's a lot of ice that's formed too, right? And so far we have blue, water, ice, or blue as water, and then we also have white as either ice or clouds as mainly being its representation. What about that green? What does that green represent? You're thinking grass, maybe prairies, forests, right? Any kind of plant material is going to be that nice green color that we happen to see. I wonder if it's mainly springtime because very much green all around, right? But what other colors do you notice? I'm kind of seeing a little bit, kind of a brownish kind of tan color. Do you see that as well? What do you think that might represent? You're thinking maybe sand, right? Or maybe rock, right? Definitely these are some other areas that are represented with that color. Now, if I go on ahead and I grab my tool right here, and I am able to just kind of spin our Earth around a little bit, and you might be able to do that too, right? Here we can see just a little bit differently, a different aspect of other countries and continents and whatnot. And so we're able to see, definitely a lot more desert, right? So we have a lot big desert here, and then we have more grasslands up above, down below, and we can even turn, oh, looks like it's kind of hard to see right here, right? But we can see all of our planet and the different colors, right? Representing all those different habitats that we have around Earth. So our goal today is to look at these colors, and sometimes these colors might have a key that helps us to get a better idea of the different processes that are going around or the different systems that we're going to be looking at. So I'm going to go on ahead and I'm going to load another data set, and you can see here are some of our data sets right here. And so this is category, will tell you right up at the top right here. And in my case right now, we're on land, but I'm going to switch us over to water. And you can see all the different options, right? You can see that there's land, people, snow, ice. So if you wanted to later on get a better look at different topics, this is a great way to be able to do that. But we're going to stick with water. And with that, I'm going to go on ahead and we're going to look at some temperature. Now, gives it a minute to just kind of load up real quick. All right. So here we have our globe. Again, whoops, and I'm going to situate it back. So you can see you can move your globe practically any way that you want to. Whoop. And you know what? I think I picked the wrong one. So let's go on ahead and try that again. There we go. All right, so it takes a minute to load up. And there's lots of different ways in which you could view these things, right? And so here we have our lovely continents again, right? We can see that. And here we are seeing, oh, looks like it's not loading at the moment. We'll go on ahead and give it another minute to go on ahead and try. But as you can see, right, here we have our sea surface temperature key. There we go. Sometimes it just takes a minute because it's like a ton of info that's on here. So here we see the sea surface temperature key, and that helps us to get a better idea of what our temperatures are. And what do you notice? I'm just going to step off the screen. And what I'm going to do is I'm going to get a chance to just kind of move it around a little. Okay? And I would love for you just to go on ahead and figure out. You could talk to a neighbor. You can send in your observations if you'd like. If you notice any patterns, if there's colors that are found in one particular area or another, feel free to go on ahead and text in your observations. What do you notice? You're going to slowly move that globe around. Now, something that I definitely notice is that I definitely see different colors, right? And these colors are found in different places around our globe. Do you see that too? A common theme, something that I definitely notice, is that there is a lot of red, right? That's in the middle. So here we have this red that's in the middle, and then there's orange kind of above that red, and then a little bit below that red too, right? So we're seeing that pattern, and it's fairly consistent as we move around our globe right here. Now, I don't see a ton of yellow, though some of that yellow does kind of mix with some of that orange, right? But then it seems to jump all the way to green. Do you notice that too? There's green up here, there's also green down here. And then, if we look even a little bit higher, it's tricky to see, but it kind of turns into, and it's, I don't know if you can see on your screen at home, but turns into kind of a teal kind of color there. So it's kind of a greeny blue. And down here, if we switch poles, right, we could definitely see that it's blue. So, if we kind of relate that to our key down here, right, what does this all mean with the colors? Well, if you're thinking cooler, right, down below, as it's definitely cooler on our scale, you got it, right? It's definitely cooler at our poles due to all that ice that we saw earlier. So it's cooler there. And then what about our middle area, right? We notice that that's pretty much around the belt or the middle of our United States, our equator of our world, sorry, not just the United States, right? We have it all being red. And why is it that it's actually a lot warmer within around the equator? Well, if we think about it, right? The position of our Earth. We are not a flat planet. We are not a cylindrical planet, right? We're not like shaped like a soup can or anything like that. We are shaped like a sphere, right? Like a circle. And so with that, there are lots of edges on our circle, right? And as our Earth is tilted, our equator gets a lot more heat than the poles do. And so we have a lot of that warmth that's being distributed around our equator area, right? So it's a lot warmer right there, as we can see just by looking at the colors. Now, of course, there's more than just colors here, right? We're seeing lots of different swirls and patterns. And I'm going to step off the screen, and I'm going to move our world around again. And I'd love for you now to focus in on the patterns that you notice. Is there anything that really kind of stands out to you? Like, are there any shapes that's kind of going on? Are there any areas where it's kind of blurry or maybe makes some sharper images or some sharper patterns? Well, something that I definitely notice, right, and this is off of our East Coast, is that we have a huge swirly area right here. What do you think those bold swirls might be representing? Talked about the color of our water. So if you're thinking water currents, the actual direction of our water and how it's moving, you got it, right? And so this is a nice, easy way to be able to see the overall pattern of the water and the currents and where it's going. So here we can see the Gulf Stream as it carries all the water up. Now for us, off the coast of California, right, we can see that there's a few currents right here, but there's definitely a lot more going on in the equator, right? So it's really neat to be able to see how all these different streams, right, of ocean water are able to move a lot from the temperature of the ocean, because actually hot and cold water helps drive movement of our oceans, but so does wind. And so let's go on ahead and let's take a look at a data set. So we're going to go back to our menu and we're going to look at winds. Oops, let's see. Let's go to, guessing that's going to probably be on land. James, is the wind one on land? Air. Just kidding, because wind is air, of course. I think I might need another cup of coffee. All right, so we can go down to air, or wind. Here we go. And it looks like we got a question of, do they ever change direction? My guess is you're thinking ocean currents. Now, the overall ocean currents within our entire ocean stays pretty much the same, which is actually how we get 5 different ocean gyres or 4 main circular patterns of our ocean. But you know, there definitely are times in which there are a lot of currents that change. Some of the currents are also due to a lot of the features that are found underneath the ocean. So different kinds of, we actually have mountains and valleys that are underneath the ocean too. Alicia, actually, I don't know if you can find a picture of that just to kind of think about. But as we think about, right, there's all these underwater features. Sometimes it's coral reefs, and so sometimes it's rock reefs or large rock structures, and so that helps actually change the difference of how the currents might move, especially if it's in like a local beach or something like that. Now, currents can definitely get stronger or weaker sometimes due to tides, and so, you know, the gravitational pull of the moon will kind of move water further inland or draw water further out towards the ocean. So there are some other factors that can be involved in kind of the movement of water itself, and sometimes storms can also change a little bit of that movement too. But it really overall, like the main ocean currents, they pretty much stay the same. So that's an awesome question. Thank you for asking. And Alicia went ahead and brought up kind of a underwater picture of of an ocean floor. So right here, we also have colors, right? That's kind of the cool thing about looking at different data sets. And we're looking more at a top-down view. So this is kind of like if we were in a helicopter looking straight down. And so what we're seeing here with all the colors, basically here we have another key. So what do you notice with these colors? It's by depth. Probably by meters would be my guess here. And so here we have purple, which means deep, right? And then as we kind of move up the rainbow, we go all the way up to like yellow or red, right? That gets more shallow. So that means the taller that some of these structures are going to be underneath the water. So here we almost have like an underwater crater, right? It's super deep down there. And then it's kind of deep here. And then here we can see kind of like a 3D ridge. So here would be like looking into like just kind of like the top part of the crater, and it happens to be really tall here, but less tall right there. And so these are some ways in which we're able to map the seafloor and see what we notice, right? And so there's a lot of things, right? It's not just the ocean currents that are working on their own. It's the land and the ocean and the winds and the position of our planet, right, along the sun that really helps move a lot of these really cool things to happen. And one thing that we definitely don't kind of think about, right, aside from our land underneath the water, is land that's above the water too. And so one example of that are actually deserts. So for instance, the Saharan desert is a great example of how land sand can actually help our ocean algae basically survive and thrive in the ocean. So here I'm going to go on ahead and I'm going to move it with our winds, and I'm just going to take it over to our Saharan desert that we have right here. And as you can kind of see the wind patterns, right? So here we have whoosh, a lot of those wind patterns. And these wind patterns are actually blowing a lot of dusty air. It's called the Saharan air layer. And what it's able to do is to be able to take a lot of that desert air and desert sand and move it over the North Atlantic Ocean. And then from there, that sand goes into the atmosphere about 20,000 feet. So all of the sand is whoosh up into the air, and eventually it lands in the Caribbean and the Gulf of I think it's a Gulf Coast actually. And so it's able to settle all of that desert sand, and that provides nutrients for a lot of plankton to grow. And so without that desert sand, many of the base of the ocean food web animals and algae wouldn't be able to survive. So it really is, we all kind of depend on all parts of the earth to create a happy and healthy ocean, which is pretty interesting there. Now, believe it or not, we do have a guest, special guest that I think will be coming in shortly. And this special guest kind of has to do a little bit with some desert lands, not necessarily the Sahara, but I have a special guest that's going to be coming on in, and we have actually two special guests. I should restate it. We have Amanda, who is one of our husbandry folks, so she takes care of our special guest and our animal here. And I won't spoil exactly what animal it is. I'll let her do that. But I'm going to welcome her and have her join us within our studio. Take it away, Amanda.
Tortoises are going to be found on land, and turtles are usually found around the water. And so just like you already heard, she's found in the desert. And so even though she's eating a tropical flower, she is a desert animal, and we'll talk about some adaptations that she has to be a desert animal. One, she has claws on her feet, so she's got little claws that help her with digging right here. And those claws are important for helping her stay nice and cool in the hot desert weather. And so you kind of dig your feet down into the sand a little bit where it's a little cooler. Well, that is something that Borrego and other California desert tortoises would do to help them to kind of maintain their body temperature a little bit lower than maybe 100 and plus degrees. The other thing they'll do is they dig holes and then lay eggs in those holes, and that helps to protect them from any predators or from being cooked by the sun or anything like that, and so it gives their eggs a better chance of surviving. Right now she's eating a flower, and in the desert they obviously don't have hibiscus flowers, those are tropical flowers, but what they do have are cactuses and cactus flowers. Now she'll eat the cactus, she'll eat that green part, she'll eat the flower, she'll eat the fruit, and inside the cactus there's a lot of water, and that's something that's really hard to find in the desert. And so she can kind of chomp away all of the spiky parts on the cactus and then find her way inside where she can get that water out of it, and that helps her to survive. She does have an adaptation to help her survive, so even though it's hard to find water, when she finds it, she can hold a lot of it in her body because her bladder can hold about 40% of her body weight. Whoa, that means if it's full, she could probably survive without finding water for up to about a year. That's a long time to go without water. But that's because of that bladder that helps her to kind of take advantage of opportunities when she finds lots of water and just to lap it all up. Now, if she gets scared though, her first thing to do, evacuate all of that water. One, that helps her to get a little lighter, so maybe she'll move a little faster, who knows. And two, it's kind of a big scary puddle that just appears out of nowhere. For the animal that might be trying to surprise her, they might get surprised back. And so that kind of helps her to survive. So that's something that's really neat about her. The other cool things are their shell. You'll notice, just like turtles, tortoises have this nice, beautiful shell on their body. Sometimes there's different shapes. Hers has some bumps. If you found a California desert tortoise in the wild, it would probably be a lot smoother because the sand would smooth it over a little bit more. But it's made out of keratin, just like our fingernails. And it is connected to her whole body. So a lot of cartoons show a tortoise leaving its shell behind, or a turtle leaving its shell behind, and then running off and doing something and then finding their way back into that shell. They don't do that. That is just a weird cartoon thing, but that is not something that they do. Their whole body is infused to the shell, so her spine is right here, her ribs are right here, and so all of those things are part of her body. So if you ever found a tortoise shell without a tortoise in it, that tortoise might not be around anymore. She's doing such a good job eating her food. I don't know if you got a closer look at her face. Let's see if we can turn her this way. There you go. If you looked at her face, another really interesting thing about them is that they don't have any teeth. So she's eating that cactus without any teeth. She's eating this flower without any teeth. And the way she's able to do that is with a beak, just like a bird. And that beak is very strong, and that actually helps her to kind of find her way into whatever food source she needs. Look at her eat. It's one of my favorite things to watch. It feels like a slow process, but it goes by fast sometimes. Now, this flower isn't her everyday diet. She gets fruits and vegetables. She gets salad. She gets strawberries, bananas, carrots, sweet potato. But this flower is something fun and different for her. We call that enrichment here. And so it's kind of like when you get chocolate cake on your birthday. Something kind of fun and extra and special that you might not eat every single day. So she's getting this hibiscus flower, and she thinks it's just like I think chocolate cake is. She's almost done. There we go. Wonderful. Now, Borrego is found in the desert system, just like you guys have been learning all about deserts. And usually people are very surprised to find that a desert animal lives here at the Aquarium of the Pacific. And I think there are some really interesting connections that you guys are going to learn about where the desert kind of impacts the ocean a little. So it does make sense that she's here. But we're going to head out. Bye, everyone.
Hey, thank you, Amanda.
Thank you.
Yeah. Wasn't that fun? Oh, almost as big as Borrego was, probably. All right, friends. So, very cool, right? We were just learning a little bit about the Saharan Desert and how it can affect our oceans and what we call the primary productivity, right? Seeing how all of these producers are able to use the nutrients that's actually found in sand to then be able to use them in the ocean. Now, Borrego, of course, goes on ahead and uses that environment in a very different way and in California. But we here at the aquarium do try to kind of make sure that we are able to relate those land animals and our ocean animals together, because as we've had a chance to just get a small glimpse in today, right? We are very much connected in all of the systems, whether it be the wind or whether it be our temperatures or our currents or even what it looks like underneath the ocean on our sea floor, right? All of that is connected and has a very special place in how our planet as a whole runs. Now, if I go on ahead, and I'm going to bring up a different data set, so that was really cool getting a chance to see Borrego there, and we look a little bit back into water, so we can go over to that data set, and we can look at one of my favorite things in the whole wide world, these primary producers, these phytoplankton, these microscopic algae that live in our oceans. And believe it or not, they are responsible for most of the air that we breathe. So if you take in a nice deep breath, right? A lot of that is due to the plankton that's in the water. So it's pretty incredible. And here we have even more colors. Told you it was going to be beautiful, right? And so here we have our oceans. And here we have if we focus, we'll switch our earth around a little bit. Here we have a key, right? Color key, because colors are fun to look at. But this time, if you're not familiar with these different types of names, they are basically different varieties of our primary producers. And so these are many of them different varieties of algae that we see here. Now, the varieties of algae for what we're going to be talking about right now isn't necessarily the important part. The important part are the colors that you see and where you see them. So I'm going to step off for a second, and if we look at it, we also have these swirls, just like our currents that we saw earlier, right? So the phytoplankton also, these primary producers also kind of move within that current system. But where do you notice most of the colors? I'm going to swirl around the world again, or twirl us around. Hopefully you're not getting too dizzy. Trying to go nice and slow. All right. So, where are you mainly seeing these colors? Now, for me, I'm seeing them in kind of like splotchy areas, right? Like I'm seeing a ton, right? Kind of down where it's a lot cooler water. So we have some down here, lots of different colors. I also see some around the equator, interestingly enough, right? And if we kind of go around, a ton up in the Arctic, right? So we have all of this area right here. But what's interesting is that there's less kind of in the very middle of our oceans, right? So we have all these kind of blank areas right here, and then we also have blank spots down here where there aren't as much plankton. Now, why is that? Why is it that most of the plankton that we see, especially right off of our US and even off of South America right here, right? A lot of it is right off of land. Well, a lot of that land provides nutrients, right? And so we have a lot of our, what we like to call our productivity, just around our coastline right here. And so that's been able to provide a lot of animals that kind of come by, whether it be anything like from crabs to fish to even whales, right? A lot of times we'll see them in areas that have a lot of these plankton nearby. And then also a lot is due to that temperature that we talked about earlier and currents, right? So it all kind of lends itself together about how many of these ocean animals are able to thrive thanks to the sun, thanks to the wind, and thanks to even the desert sand. All right, friends. Well, unfortunately, we are out of time today, but feel free to keep on exploring using that Science on a Sphere application and see what kind of cool things you get a chance to notice from all these wonderful data sets. Now, if you do have any questions, you can go on ahead and email us at live@lbaop. And teachers, if you happen to be watching out there, we'd love to have any kind of numbers. So if you want to text us in the amount of students that you have, that would be extremely helpful that are also watching today, because this helps us to get an idea of how many folks are watching and enjoying this content, but it also helps us to get a better idea of how we prioritize our program. So we'd love to hear from you, and just a thank you in advance for texting in the student numbers. We definitely greatly appreciate that information. So once again, thank you, friends, for joining us. Hopefully now you too are even a bigger fan of Earth and of desert tortoises like Borrego. All right, friends, have a great rest of your day.